what we're doing is really to lay the foundation, right? You can't launch an EC2 instance without actually having a VPC. And that's the reason why we did that lab first, right? What we're going to dive into now is EC2 and what it is, right? We're going to take a look at some of the instance types that exist and what are some workloads that actually, are better for some specific instance types. For example, if you're running Spark jobs, right? What instance would I recommend that you use, right? And that's going to be the memory-intensive EC2 instances, as it's cheaper for memory for those instances. So this presentation will introduce EC2 and dive into what it is and what the functionalities are and what are some best practices when working with EC2. The lab that actually follows this will allow you to launch an EC2 instance within the VPC that you guys create. Now, after that lab, we will dive into fault tolerance and high availability on AWS. And we'll dig into how we can actually design environments within your VPC using EC2 and EC2 services to accommodate for fault tolerance and high availability within the environment, leveraging multiple availability zones, right? And services like auto-scaling and elastic load balancing within AWS, right? So what we're really doing is building up to that grand finale, right? So what does the terminology EC2 stands for, right? It simply stands for Elastic Compute Cloud, right? That's a terminology coined by AWS. And to interact with EC2 within AWS, you need an Amazon machine image, right? If you go inside the EC2 console today and try to launch an EC2 instance, the very first thing you do is to actually choose this, what we call an army, right? Now, we already have pre-built armies. So if you're looking at launching a Red Hat server, for example, we already have an army built for Red Hat, right? And we try to keep these images up to date with the latest releases. Now, you can actually import your own armies, right? So if you have your own virtual machines running on premises, let's say, for example, you're running VMware on premises, and you want to move a machine from your VMware environment into AWS, you can simply download the vCenter plugin for vCenter and use your VMware environment to manage your AWS environment and to migrate virtual machines into and out of AWS. Now, you cannot migrate an Amazon-built army image from AWS, but you can always move your virtual machines that you import into AWS, you can always move them back and forth, all right? So what we've actually done by doing that is allow you to actually leverage knowledge that you already have, right? What if you only want to build a VPC and move and work with EC2 instances? You can simply do that from your vCenter environment, right? Now, again, when we just launched, we launched with what we call Ec2 Classic. And Ec2 Classic allowed you to build EC2 instances outside of the concept of a VPC, right? Where you can simply just click on launch an instance type you want, and boom, an instance is actually inside your account, and you can connect into it. But today, we don't allow that anymore. That service is actually considered to be Ec2 Classic, and you don't necessarily have access to Ec2 Classic if you have no Ec2 Classic instances existing. What does this mean? This means that what we just did a while ago of creating your VPC environment has to be done, right? And again, it has to be well thought out. I wouldn't recommend starting to interact with the AWS environment if you don't have your definition of success, right? Now, along with EC2 comes storage, right? What does storage look like? Well, so far we've spoken about S3, and S3 is really our object-oriented storage. And the idea behind S3 is that you can store anything inside of it, right? There's no limitation to how large your S3 bucket can grow. It grows indefinitely, right? There is a limitation on the size of the object that you can actually upload, right? And that's a 5 gig file is actually the largest. Now, what about actually attaching storage directly to my EC2 instance. How do I do that? That is done through a service called Elastic Block Storage. And it really mirrors the whole concept of SAN storage that you guys are quite familiar with on premises, right? So this is block storage devices that you can attach to an EC2 instance. And there are many advantages that come with doing that. One of which is that I can run an instance today, and I can store a bunch of information on my block storage, and I can delete my instance, but that storage lives outside of my EC2 instance. And I can actually create a machine image from that block storage device and create a new EC2 instance that has the configuration, that has the data that block storage device has on it. Right? Now, EBS lives on a platform independent of EC2. What that simply means is that when you're writing data to an EBS volume or an elastic block stored volume, you're writing that data across the wire. You're writing that across the network. And because of that, some instance type allows you to actually have dedicated network bandwidth that communicates with the EBS platform. Some instance types carry 750 megabits per second, and you have some instance types that carry 10 gigabits per second. It all depends on what you guys are trying to achieve. Right? Now, an EC2 instance can only live within a specific availability zone. So if I create one EC2 instance entity, I can't spread that one instance across multiple availability zones. What I can do is actually create a machine image, right, and implement replicas of that instance across multiple availability zones. The block.
What's the difference between the elastic block storage and the S3?
So elastic block storage is directly attached to your EC2 instance, which means you mount it onto your EC2 instance, right? And that's block storage as well, which is completely independent of the idea of object-oriented storage, right? S3 is what we call a public service, which means it lives outside of your VPC environment, right? The relationship between EC2 and EBS is very tight. It's as a matter of fact, EBS volumes are mounted directly onto your EC2 instances, as you would actually have a virtual machine within your SAN environment communicating with different LUNs.
Just to add to that, I mean, it's like a file system for your
Yeah.
instance. So you can decide the amount of hard disk to put on your instance and mount it. That's what EBS is for.
Yeah. And just to piggyback on that as well, so EBS allows you to choose different storage types. You guys are familiar with the concept of tiered storage, right? You can actually have HDDs, right, magnetic disk, where you write data onto those volumes that are not necessarily accessed a lot, and you don't need high performance from them. But if you need high performance storage, we're looking at SSDs, right? And you can choose different variation of SSDs for your as your EBS volume. So if you're looking at applications that need to write that need thousands of IOPS, right, which means that they need to be writing a lot of data onto this EBS volume, then you can choose what we call general purpose EBS volumes that can scale up to 3,000 IOPS. Or if you need more than that, you can actually get what we call provisioned IOPS volumes. And you can actually get significantly more IOPS with less storage volumes. These are all SSD based, by the way. Now, how do I back up these volumes, right? The simple answer behind that is that we use what we call snapshots. So if I have an EBS volume, for example, I'm running SQL Server, right? I have my own always-on availability groups, and I'm using EBS volume as a mechanism to store my data, right? If I want to snapshot my databases, or I want to back up these databases without interrupting, for example, their availability, then I can do that via snapshots, right? And snapshots is not a backup in the sense where you have to load it from cold storage. No, they're actually readily available. So if something happens, right, and I need to recreate that instance, I can do it from these snapshots. All right, and it's not going to be a rebuild where I'm rebuilding the machine. I'm simply going to be relaunching a machine from an army created from that snapshot. No, you're not getting it wrong. So the beauty about EBS is that you can actually, if you need to scale up in terms of storage, you can scale horizontally. So what if I started with a 10 gig drive, right? But I need 100 gigs. I can simply add I can create a 90 gig volume and mount that onto my instance. EBS by default comes with a mirror mechanisms, which means we're creating a complete replica of that EBS volume within one availability zone or one hardware, right? Which means that if I need RAID 1 plus 0, I don't necessarily need. I can forget about the mirroring option and focus on striping, because your data is being backed up or replicated, I should say.
But if I wanted to add storage later on, can that be adjusted or
Add a new EBS volume. Yeah. Any more questions? Okay. So the relation to buckets in this particular slide is that when you create a snapshot is actually stored in S3. So the idea behind Amazon is that we don't create a platform in which each service is actually isolated. Each service interacts with each other in many cases. So what you'll find is that S3 is that storage mechanism that stores a lot of, for example, snapshot volumes, right? Or it allows you to actually push data to a bucket and allow another service to consume that data. And a simple case of that is simply this. What if I actually want to consume my log data from my web servers in real time, right? Then what I would simply do is use Amazon Kinesis Firehose, right, to constantly monitor my log file. And every time something is written to that file, I grab that data, store it in S3, right, and allow that data to actually be manipulated, for example, by running a Hadoop job on it, right? Or I can actually use a Lambda function that transforms that data and store that data in DynamoDB, in DynamoDB, or store it within Redshift. So S3 is that midway or point, right? Or that storage mechanism that we can use for many different purposes. When it comes to EBS, it has a specific purpose. As a matter of fact, the cost structure between EBS and S3 is different. So when you look at S3, it's 3 cents per gigabyte, right? With EBS, it's 10 cents per gigabyte. I don't think we can speak enough about the VPC and the relationship between that and EC2. So let's talk a little bit about the different instance types that exist. So today we have several different instance types. We have the general purpose instance types, in which the ratio between compute, storage, and memory, right, allows you to run a simple application that doesn't necessarily is overbearing on either of those components, right? But what if I need to run a Spark workload, right? I wouldn't necessarily use my general purpose instance types for that. I would use an instance type that provides me with a lot more memory, because Spark is an in-memory processing solution, right? So I would actually look at using the R3 instance type. And the R3 instance type provides memory at a much lower cost than you would get with the general purpose instances. Now, of course, these instance types or instance class allows you to spin up instances with over 100 gigs of RAM, right? And again, this is an on-demand environment, which means if you need to test a workload, for example, you can easily spin up an instance that has 244 gigs of RAM, right? Check to see if your application is consuming all of that. If it's not, then you can reduce the instance size to something else within the same class to see if that best fits your use case, and then get rid of the instance when you're done, right? And we start billing you for that. So that's the whole idea of the elasticity of AWS, right? You have the ability to go in and say, okay, you know what? I have this workload. I have no idea, you know, what the requirements are to run it. Amazon Web Services allows you to actually spin up instances on demand, test these workloads, create a benchmark, right, as to what the optimal performance should look like, or what the optimal instance type should be for that workload going forward. So you're really paying for what you need, right? And the elasticity of Amazon actually allows you, or the depth and breadth of Amazon EC2 service allows you multiple instance types that you can choose from to see which best fits your workload. Go ahead.
When you switch between the different instances in the scenario you're talking about,
Yeah.
you lose all the data on your EDS?
So, very good question. There are two types of two instance types, or classes, or categories of instances. You can create your EC2 instance from what we call an instance store-backed image, right? With that, when you stop your machine, it's just like terminating it, right? If you have an EBS volume attached to it, the EBS volume can persist outside of that instance, so you can recreate a new instance and attach that volume to it. Or you can actually choose what we call an EBS-backed EC2 instance type, which means that everything is being built from an EBS image, right? You can stop that instance, you can change the size of that instance, you can restart it. You can really interact with it as you would a server on-premise, right? So it's really important that you know which instance type you're instantiating, because the functionality varies. Yeah.
What is typically more compute optimized? And also, have you seen a combination of like your worker nodes and your task nodes having like different instances, and where some of these instances fit out?
So we do see that. So I guess you're referring to Hadoop, right? So you can actually use the C instance class, whether it's a C4 or C3, and the C class is actually compute optimized, which means compute resources are much cheaper than it would be on a standard or general purpose instance type. You can mix match, right? So you can actually choose instance types that are much larger to be your master node, right? Is everybody aware of the X1 instance type? No? So the X1 instance type was launched this year, as a matter of fact, a few weeks ago. And it provides nearly 2 terabytes of RAM and over 100 cores on a single instance, right? So if you're running workloads where you want a huge master, where you want smaller instances to be your worker nodes, then you can go ahead and do that.
So regarding the S3, so what's the IOPS of S3 bucket actually? So if I have to compare between just the IOPS, where it stands?
So it's a good question. A lot of times I hear that question. So the question is, how do I compare the IOPS of S3 to an EBS volume, right? And the answer is we don't necessarily measure S3 in terms of IOPS, right? But we measure it in terms of, how many transactions per second am I going to be putting into S3, right? And we create or provide best practices to optimize, to go beyond the limitations of S3. We can actually take that question offline. But the short answer is EBS is much faster to write to than it is to write to S3, right? Because remember, you're writing to a public service versus a volume directly attached to your EC2 instance, right? So you can, go ahead.
S3 will be replicated across all the availability zones.
Yes.
And every region, right?
Within that region.
Okay.
So S3 is your object. When you store an object in S3, and I guess this is the difference between EBS and S3, that single object is actually taken and replicated multiple times across multiple availability zones, which means we're writing that one object across multiple data centers. across multiple devices within that data center, right? And if the image is actually, if that object is actually corrupted, we can recreate that from a version of that exists in another data center. And we do that. We actually monitor and do that for you behind the scenes. So when you look at EBS, you don't necessarily have you don't necessarily have to actually write code to get the IOPS that you need, right? You can specify when creating the volume how much IOPS you're gonna need based on the volume of storage. With S3, if you want to grow beyond the default limitation, you have to actually modify your key space to get that kind of performance.
S3 also have limitations in terms of API calls that you may not necessarily have with EBS package storage. I'm trying to get a bucket like very frequently upload like massive amounts of data. Sometimes when you hit the storage, the API call threshold, the request or something.
So it's not necessarily an API call threshold, right? What happens is S3 is a serialized storage, which means if I'm writing a bunch of data, for example, I'm writing data and I'm using the date and time as the a part of the key space. What's going to happen is that we're going to overload a single partition because we're going to write all of that key space onto a single partition. To overcome that, what we do is to actually create a hash, an MD5 hash of probably the object name, and apply a randomized or a unique value to that key space, right? So that we are writing across multiple partitions instead of just one single partition.
What you might be actually referring to is the API throttling. I mean, let's say you keep calling the same APIs again and again, you get throttled. That's not true only for S3. I mean, that's true across the board.
Yeah.
In AWS, where you have to like stay within limits, otherwise request limit increases. These are all soft limits that we apply on our side.
And one primary example of that, and given that we're on EC2, is that if you're going to be launching thousands of instances or even hundreds of instances, right? It's important that you submit a ticket for us to actually increase the number of EC2 instances that you can launch. By default, the limit is 20, right? And that's a way to protect us and a way to protect you as well, right? We won't dive into identity and access management in this presentation, but what happens if your key becomes public and somebody decides to spin up instances within your environment, right? And you're spinning up large instances. Then a way to actually cap that is by limiting the number of instances that you guys can instantiate. But if you have specific workloads that need more than 20, you guys can submit a ticket and we'll increase it for you. It's not a problem. So we've been talking a lot about on-demand, right? And yes, the Amazon environment is an on-demand environment, which means you request a service, we give it to you, you do away with that service, and we stop billing you for it. But what if you actually have a workload that I'm not going to get rid of these instances. This is my production environment, right? These instances are going to be around for 5 years. They're going to be around for a year, for example. How can I negotiate with Amazon, for example, for a lower cost, right? And the answer to that would be reserve instances, right? Reserve instances allows you to reserve capacity. And when you reserve that capacity for a given period of time, let's say you reserve it for a year, then you get discounts that reduces your costs from using on-demand instances, for example. So what we've seen is that customers get 30% or run their environment for 30% less or more, right? But what happens if I have a Hadoop cluster, right? And I have a replication ratio within that cluster of, let's say, 3:1, which means I can actually lose an instance, but I still have that data running on another instance. I can launch a new instance, add it back to the cluster, and continue my processing, right? How can I actually reduce my costs for running large jobs using hundreds or even thousands of instances? What a lot of customers are actually doing these days is that they're using spot instances. And spot instances allow you to bid on Amazon compute capacity, right? Or let's say extra capacity. And because you're bidding, right, what you generally find is that it's significantly less to run your workload on a spot instance than it is to run it on an on-demand instance. And a lot of customers actually have a mixed bag environment, especially when you're looking at big data workloads, where they have, for their master or their head node, they have a on-demand instance, right? But for their workers, they have a mix of on-demand and spot. And they can achieve cost reductions, sometimes 40%, right, than running on-demand instances.
There's no guarantee you'll get a spot instance, is there?
There's no guarantees, no. Yeah.
And what happens once you're, I'm assuming the spot price can change since it's a bidding process?
Yes.
It says your spot instance runs while your bid is greater than the spot price.
That is correct.
Does that mean halfway through whatever it's running, if the spot price rises, your instance just dies in the middle of your processing?
The answer is you will lose that instance. Is there a grace period? We do notify you that you're going to be losing that instance.
What kind of grace period? 2 seconds? 2 hours?
It's definitely not 2 seconds. I can send you the grace period after this slide. But we've actually matured the spot instance service itself. So one of the things with AWS, right, we don't just release a service and that's it for that service. We continually iterate on that particular service. And when we get feedback from customers, we're constantly building to meet those requirements, right? So what we've actually done, one of the limitations here with spot instances is that you can't actually see how many spot instances are available, right? And there was a constant request from customers. So what we've actually done is to take that feedback, and we've actually launched a service called Spot Fleet. And Spot Fleet allows you now to actually spin up EC2 instances from multiple EC2 buckets. So you can have R3s, M3s running for a particular workload, and you can actually know how many instances are actually left within that bucket. So say if you're running a workload and you're like, you know what, I'm going to need compute, but there's only 10 compute resources within a particular bucket for the C class, then you can look at another instance type, and you can actually do a mix between instance types running on your spot service. So again, we have customers running a mixed environment of spot, on-demand, reserve instances, right? Any questions? Okay.
So, one question though, it's the reserve instance once you have purchased for 2 years or whatever,
Mm-hmm.
and you continually keep on reducing the price, right? Will I get benefit of that at a later point?
So that's an answer I don't have for you. I'd have to actually get back to you on that.
Okay.
Yeah, because there are multiple ways you can actually pay for reserve instances, right? You can decide I'm going to pay for my reserve instances upfront, right? So for example, if I know I'm going to be using 5 C4 large instances, for example, for the year, I can actually pay for those instances upfront. In that case, the answer is no. All right. But you can also decide I'm going to pay half upfront, and I'm going to pay the rest over time. Or I'm not going to pay anything upfront. I'm going to pay for them over a period of a year, but I'm committing to AWS that these are going to be here for a year. I'm going to use them for a year.
So I'll get, yeah.
So in that case, I need to actually check and get an answer for you. So the question was, what if I decide to use reserve instances, but midway through the year, Amazon reduced the cost of that instance type? You know, do I inherit that cost reduction? All right. Any more questions before I move on? All right. So, who today are running a VMware or a Hyper-V environment on premise? VirtualBox. It's a VirtualBox. VMware as well. Okay. We spoke a little bit earlier about actually importing your images into AWS, right? You can use the vCenter plugin, which is the easiest way to do it. You simply just download that plugin from us, and it gives you an Amazon category within your vCenter console that basically lists out, the EC2 services that you have running within your AWS account, etc., and how to actually manage that from that console, right? Or you can actually move your image into AWS and decide, I'm going to use the API calls within AWS to import that image and transform that into an EC2 instance. But if you have VMware, I always recommend going the route of the vCenter plugin. A question I get a lot is actually around, what does security look like? Can somebody actually sniff my packets? Because AWS has a multi-tenant aspect to it, right? Where virtual machines are being hosted on a single appliance. So you can have multiple EC2 instances belonging to different customers running on that one appliance, right? What does security look like for that? And the answer is, there is actually a firewall that's built into the platform itself, right? That keeps track of whose traffic belongs to who and prevents anyone from actually sniffing those packets. As a matter of fact, we're so security conscious that if you're even going to be doing a penetration test into your environment, you have to let us know, because we're going to flag that traffic. And we either shut down that instance or we ask you to shut it down, right? Or shut down that attack. So, you see the AWS environment running, but there are a lot of security mechanisms built into the platform itself. And we're constantly monitoring our environments, right? Now, one of the things that you'll see later on is that we don't have access to your data, right? Within Amazon, we can't access your data. We've put measures in place that actually prevent anybody except for you to access your data, right? So when we refer to monitoring the platform, we're monitoring the performance of the instances on the platform, on the health of the EC2 platform itself. Now, what happens when I actually delete an object, actually delete data from my EBS volumes, right? Because again, these are volumes directly attached to your EC2 instance. Now, when you issue a delete API call for an EBS volume, we zero those drives, right? An advantage of that is that when you actually launch a new EBS volume and attach that to an EC2 instance, all sectors are already hot and ready to be written to, right? So the performance that we provide on our website is the performance you'll be getting right away. There won't necessarily be a lazy write to your volumes. But what if I'm actually loading data from a snapshot? What if I did a snapshot of your EBS volume, right? And you have actually decided I'm going to recreate an EBS volume from that snapshot, right? What happens, because that data now lives within S3, we have to load that data on that EBS volume, right? So you may find that data that you're readily trying to access is loaded faster onto your EBS volumes than all the data itself. And we generally call it a lazy load, right? Where we're lazily loading data onto your EBS volume, right? Has anybody heard of that concept before? No? Okay. Now we've spoken about that. And this is actually what the structure of EC2 looks like, right? Where you can actually see the firewall living between the physical interfaces and the different security groups that you guys create. So the security groups that you guys create falls below the virtual interface. Now, because of this structure and how decoupled it is, right, we can provide added functionality and added performance for you. So what if you actually have, let's say you have a Cassandra cluster, right, and you need to achieve millions of writes per second, right, or over a million writes per second. What you can actually leverage is something that we call enhanced networking, right? That where we actually bypass the virtual network control mechanisms and allow you to speak directly to the physical hardware. And by doing that, we can now allow you guys to achieve faster writes than you would without activating enhanced networking. Later on, when we are doing the Ec2 lab, you guys will see security groups within the Ec2 console itself. But not to be alarmed, this is not different from the security groups you guys created or the security group concept within the VPC. As a matter of fact, it's the same thing. The reason why it's still within the Ec2 console is because we still have customers using Ec2 Classic. And Ec2 Classic, you must have security groups, right? No matter what, you have to have a firewall that protects your Ec2 instance. But it's still the same security group. You can configure it whether within the Ec2 console, or you can choose to configure it within the VPC console. And again, the same concepts applies here. We have a much prettier graphic here that illustrates applying specific security groups based on a specific use case or application need. So Ec2 instances that need to speak to the database servers will have to have access to port 3306, right? But if an instance doesn't necessarily need that, that's not its use case, you would not have that port open within its own security group. And that's the whole idea around security groups. I only have ports open that needs to be open. So it's an as needed basis, right? And that's one of the primary best practices when working with security groups. And again, we never recommend that you have a single security groups with all the ports that you need open. So how do we ensure that nobody but you actually have access to your Ec2 instance, right? We achieve this by using a key structure, right? Where in order to actually instantiate an Ec2 instance, you must have a key pair. And within that key pair, you have a public key and you have a private key. So when you create an Ec2 instance, you also create a key pair, right? You can have one key pair that many Ec2 instances use, or you can decide I'm going to have a key pair per use case, right? Now, let's look at Windows. If I instantiate an Ec2 Windows instance, right, the key pair that you generate is actually used to decrypt the first admin password for your server. So you can't get access to that server without having downloaded that private key. Amazon does not have access to that key. We never see that key, which means if you lose that key, we can't help you, which means we can't generate that key back for you, and we don't have a stored copy of it. So we always recommend that you store your private keys in a safe and secured area, right? When it comes to Linux, the private key is actually used to SSH into your Linux box. Any questions? So the last lab we're going to be doing today, right, that's the one after the Ec2 lab, is where we create, is where you guys will use an Amazon machine image that I created, right? I created an Apache web server built into that army, and I built a web page that pulls the metadata from your Ec2 instances, right? Now, every Ec2 instance has this metadata file, right? And I can send, I'll actually publish the metadata link or address space that's the same for every Ec2 instance. And it allows to actually see the instance ID, the instance name, how many instances were created from that same Amazon machine image that you have running within your environment. So let's say, for example, you created an auto-scaling group, right? Or a simpler example, you have a database environment. You have a master node. Now, the master node actually has an index of 0, right? Because that's the original copy. You decided to actually create an image from that master node and instantiate replicas, right? Those replicas would have an incremented value. So how can I actually perform certain tasks on those nodes during launch time, right? I can pull the index number, right, evaluate it, and then perform a specific action on my instance if it has a value greater than 0 during launch time. And that concept is actually referred to as bootstrapping. That's where I can actually perform multiple operations during the boot of my Ec2 instance. So if I need to actually download and install Active Directory on an instance, right, I can actually write a script, add it to what we call the user data of that Ec2 instance, and that script is actually run while the instance is booting. So while it's booting, it's downloading Active Directory, it's configuring Active Directory, right? So you don't necessarily need to touch the machine itself after it's booted, right? You just need to know that you can connect to it. So everything that you need for that instance can be loaded onto it during boot time. And that's the whole idea behind bootstrapping. Any questions? So outside of bootstrapping, right, what if I don't necessarily want to download anything while my instance is booting? But when my instance is booted, I want to ensure that multiple services are started. So for example, if I have a Linux machine running and I need to actually have Apache Squid downloaded on it, right, I can already have a machine image that have all of those resources on it already. And at boot time, I can specify a script that start these services for me, which means that I can instantiate an Ec2 instance, and as it comes online, my customers or my clients can directly interact with it without me having to do anything else to it, which means that I can add it to what we call an auto-scaling group, or I can add it to an elastic load balancer, right, and accept traffic right away once it comes online. The public key for your Ec2 instances is visible within the metadata of your instance, right? The Amazon machine image that I created is publicly accessible, so you guys can use it to even outside of this lab, right? To actually look at what the metadata for your instance is. And that's another thing with Ec2 instance as well. If you guys have created a machine image and you think the broader AWS and community will benefit from it, you guys can make that image public, right? I always recommend not to have anything, any security, any sensitive information on it, any keys on it, right? Before you make it public. And this is what the metadata looks like. And this is a limited list of the metadata itself, right? Because there are different prefixes that you can add to, for example, network, right? I can look at what the MAC address is for my Ec2 instance, as well as I can look at the security group it belongs to and the subnet group it belongs to, all right? And all of this information you can actually pull from your instance. So traditionally, when developers wrote applications, right? So for example, I'm writing a web application that needs to interact with S3, right? Instead of passing key information to S3 from a text file, I can actually create a role within the identity and access management platform of AWS, specify that role to S3, and S3 will actually query the metadata of the Ec2 instance to find out if it actually has access to a particular bucket, right? And that's actually, that's one of the ways that we've built security and remove the need to do that from your applications, right? Any questions? Okay. So, I know it's time to actually do the second lab. So in this lab, we'll be creating an Ec2 instance that will be a part of the VPC that you guys created earlier. and we will be connecting to it as well. So what I've done is to actually gone ahead and create instructions for people who prefer a specific operating system. So if you're a Windows guy or gal, you can spin up a Windows machine, and there are instructions on how to connect to that one. If you're a Linux person, there are instructions for Linux as well. And this lab will be 20 minutes. So any questions before we start? No? Given that we're strapped for time, for fault tolerance and high availability, I will actually build that. I'll demo that live for you guys.